Hi class, good day. So this discussion is about parametric statistical inference. Okay, so I hope you already see what's on my screen. Again, this is about parametric statistical inference. So what are the different parametric tests? Parametric test includes your t-test, z-test, f-tests, and your ANOVA. Non-parametric test includes your Spearman rank correlation test and your chi-square test. When you say parametric statistical inference and the non-parametric uh, inferences, the difference is yung parametric test from the word itself. This actually analyzes the parameters of population by drawing samples within that population, but this is dependent through the distribution of statistical data, while your non-parametric tests are not dependent to the distribution of data, meaning they are distribution free. Okay, so let's focus on parametric statistical inference because this will be all about our topic for today. Okay, so let's proceed. Parametric statistical inference, there are two kinds. It could be estimation of parameters or it could be hypothesis testing. What is estimation of parameters? This is the estimation of a known population by the known sample values. While hypothesis testing tells whether there is significant difference or not between the studies. So it may sound alike. Ano ba yung pagkakaiba? Because estimation of parameters and hypothesis testing might be similar in many aspects, but please know that estimation of parameters is different from hypothesis testing. Because when you say hypothesis testing, this tells whether the results has significant difference from each other. While the estimation of parameters, it tells you how much is the effect. For example, the effect of treatment or studies dealing with treatments. If the hypothesis testing, it will tell you if there is significant difference between treatment A and treatment B or the previous and the present treatment. While estimation of parameters is actually, it will tell you how much is the effect. Okay, so let's proceed. Again, estimation of parameters and hypothesis testing are two kinds of parametric statistical inference. First, yes, this one, estimation of parameters versus hypothesis testing. So, yung hypothesis testing, yung goal is to test a hypothesis about an unknown parameter, usually the null hypothesis, which states that the treatment has no effect or not significant. So, hypothesis will really tell you if there is significant or no significant difference between the results. Well, estimation is to estimate the value of a known parameter. Okay, I'll not go over with this already. I'll leave it to you. So let's proceed to the next slide. Estimation of parameter muna tayo. There are two classifications. It could be point estimation and interval estimation. When you say point estimation, these are single value and has an advantage of being precise. Okay? When we say precise class, these are values that are repeated and they follow closer or the same values upon repetition or upon trials. So example of point estimation is estimating the mean age of the students at the state college is equal to 21.50 years. Okay? Mu there stands for, again, your population mean. So this is point estimation, it is direct, exact. So when you say the mean age of the students at the state college, meaning yung mga ages ng students doon, yung average age is 21.50 years. And that is point estimation. When you say interval estimation, these are only range of values and has an advantage of providing greater confidence. Okay? Don't worry, we'll discuss this in the next slide. Just remember, your interval estimation is also called as your confidence intervals. Okay? Pag magkataas yung confidence intervals, um, it has also bigger impact to your interval estimation. So interval estimation provides greater advantage to your confidence to your level of confidence. That's why it's also called as confidence intervals. Example of interval estimation is estimating the mean age of students at the state college is population mean is equal to 20 to 30 years. So again, yung point estimate single value lang, it's direct to the point 21.50 years. Yung interval estimation range of values, and it's also called as confidence intervals. Okay? So are we done here? Let's proceed. So ito yung tabulation of the confidence intervals. This is your z-test class based on your z-test. So ito 90%, 95, 99, these are your coefficient confidence or confidence coefficient. And this one, alpha, denotes by the Greek letter alpha, stands for level of significance. So that's 0.10, 0.05, and 0.01. And this one stands for your critical value. And this one is the level of significance, this time two-tailed. Ito, one-tailed lang ni silang duha, one-tailed. And then this one is two-tailed na level of significance. And this one is your critical value, uh, two-tailed. Okay, two-tailed ni silang duha, and then kani sila is one-tailed. How do you get the level of significance? Let's proceed. So confidence coefficient, it's 1 minus the level of significance times 100. So for example, 0.05 or 5% yung level of significance, 1 minus 0.05 or 1 minus the level of significance times 100 is equal to 95%. So 95% yung probability of accepting your null hypothesis. Ito yung meaning ni confidence coefficient. Okay? So ito yung 95% probability of the accepted region. Yung level of significance, it's denoted by the small Greek letter alpha. When you say 5% na level of significance, this one, it means the researcher is willing to commit 5% of type 1 error. Bakit type 1 error? So these are the two types of error class. You have type 1 and type 2. Type 1 is denoted by a Greek letter alpha, and type 2 is denoted by your beta. Type 1 occurs when the researcher rejects the null hypothesis when it is true. So yung level of significance, you have 5% chance of the researcher to commit an error na na-reject niya si null hypothesis, but then that is actually true. Okay? That is your level of significance denoted by the alpha Greek letter. Your type 2, your beta type of error occurs when the researcher, this is the opposite, accepts the null hypothesis. Na-accept niya when it is actually false. Okay? So I hope this is clear. These are the two types of error, type 1 and type 2. Yung level of significance is denoted by a Greek letter alpha. Okay? So let's wait a minute. Okay, so let's proceed to the next slide. This one is your one-tailed test. This one is your two-tailed test. Okay? So, I'll show you. Itong naka-red, ito yung level of significance. That is 5%, meaning 5% chance of committing an error. It could be also 1%, 10%. It could be also 1%. The one represented here in the table, 10%, 5%, or 1% level of significance. Okay? Again, how do you did you compute the confidence coefficient? That is 1 minus the level of significance. Okay? Next class, let's go back here. This is your um, rejected region. Ito yung rejection na region, this level of significance. Meaning, again, this is the chance, the willingness, the percentage na pwede mag-commit ng error si researcher of rejecting the null hypothesis which is said to be true or totoo. Okay? And this one here, the 95%, this is your confidence coefficient. This is the accepted region. This is an example of one-tailed test at ito yung two-tailed test. Okay? Saan dito yung critical value? This one, the middle, this one, the line, that's the boundary. Okay? Meaning until dyan lang, pag maglagpas na greater than the critical value, that already means that it should be rejected. Anyway, we'll be computing step by step later. So again, ito ang example ng one-tailed test at ito two-tailed test. When to use one-tailed test and when to use two-tailed test. One-tailed test is appropriate class if you only want to determine if there is a difference between groups. There is significant difference in a specific direction. But if you're not sure of what test to use, you may use two-tailed test. But between these two, yung one-tailed test is statistically more powerful because it gives you chance more or there is more likely na yung studies is maging significant. Okay? So, one-tailed test is more appropriate or statistically powerful than your two-tailed test. Let's proceed. We're done with estimation of parameters. We are now in hypothesis testing. This is the second division of your or types of your parametric hypothesis, parametric statistical inference. So there are two hypotheses that you might establish or construct. It could be null hypothesis or alternative hypothesis. When we say null hypothesis, the hypothesis to be tested is this is the hypothesis to be tested. Yung null hypothesis talaga, siya yung parang basis. This is the hypothesis of no effect and non-significance in which the researcher wants to reject. So ito na yung pinag-usapan na 5% level of significance na pwede ma-reject ni researcher, but then they might commit the type 1 error na pwede siya maging true yung null hypothesis but it was rejected instead or wrongly rejected. Number two, alternative hypothesis. When we say alternative hypothesis, the hypothesis that is to be considered as an alternative to the null hypothesis, meaning this is opposite or contradiction of the null hypothesis. So example here, the null hypothesis is the average grade of the students is 50, meaning equal to 50. While the alternative hypothesis, the average grade of the students is greater than 50. Pwede po the average grade of the student is less than 50. Pwede po the average grade of students is not equal to 50. This is an alternative or an opposition to that of the null hypothesis. So again, two hypotheses, you have null and alternative hypothesis. So here, you have your two-tailed versus your one-tailed hypothesis test. Again, ito yung two-tailed. In your two-tailed maging class, this is 0 and this is the positive side, negative side. In your x-axis, di ba, you have here the negative, dito, then positive. So, you can mas bugat iyahang critical region, no? Kay malapas lang ka diri gamay that will be rejected already and also in here pwede na siya ma-reject. Si one-tailed test is statistically more powerful. There will be more chances of giving or providing significance sa inyong result. So this is one-tailed test or also known as left-tailed test. Actually, it's not known. So I'm sorry, guys. It's not also known as left-tailed test. When the picture it just shows a left-tailed test. Okay? Pwede naman dito sa right. Okay? So next, what is a decision rule? I have here questions. What is a decision rule? What is a critical region. What is a critical value and what is a acceptance region? So when you say decision rule, this is the region, yung critical region. Um, this is the criteria whether or not you accept or reject the null hypothesis. So that's your decision rule. When you say critical region is the area under something distribution that includes unlikely sample outcomes. Your critical region is also known as your rejection region. This is the area where the null hypothesis is rejected. So let's go back. Itong mga naka-black, ito yung critical region. Okay? Again, yung decision rule is a criteria whether or not you will accept or reject the null hypothesis. What is critical value? In here, yung line dito, it's the critical value. That's the boundary. We say critical value, ito yung the value between the critical and the acceptance region. So ito yung acceptance, ito yung critical, at ito yung critical region or the rejected region, ito yung acceptance region. This one, the line or boundary in between is actually your critical value. How do you compute critical value? There are statistical tables that will help you determine the critical value. Okay? What is an acceptance region? So ito yung acceptance region yung nasa puti. Meaning, they are accepted. Okay? Remember, class, as the level of significance increases, the size of the critical region also increases. Okay? So, again, yung level of significance, pag nag-increase po din mo critical, the size of your critical region. Thus, your null hypothesis is rejected at level of significance that is higher. So magkataas ang level of significance, there will be more chances or it will be more likely rejecting also your your null hypothesis. Next, hypothesis testing on means for one or two sample cases. So I have here z-test versus t-test. If alpha is known, the test statistics to be used is z-test. But if it is unknown, you use t-test. However, class, if the total number of samples or the total number of observations is greater than 30, you always use z-test. Regardless if it's unknown, yung population, standard deviation. Kasi yung z-test is for larger sample size, yung t-test it's for smaller sample size. Okay? So again, this is your z-test versus your t-test. To test on means for one sample case, you have this formula, you familiarize or you write down this formula. Ito yung gagamitin natin in the next succeeding slides. In the succeeding slides. So example, we have our first example. An instructor gives his class an achievement test, which as he knows from years of experience, yields a mean of 80. His present class of 40 students obtains a mean of 85 and a standard deviation of 8. Can he claim that his present class is a superior class? Use level of significance 0.05, meaning 5% na naman yung chance of committing an error na pwede na wrongly accused na rejected si null hypothesis despite of it being accepted unta or true. Okay? So let's solve the problem. Let population mean be the mean grade of the present class. Step 1, set up the null and alternative hypothesis. There are 5 steps, Rajod. You first set up your null and your alternative hypothesis. So your null here, there's no significant difference between the mean grade of the present and that of the previous class. Okay, walang significant difference. For the alternative, there is significant difference between the mean grade of the present class and that of the previous class. Or it could be the present class is superior or higher than the previous class. So that's how you set up your alternative and your null hypothesis. Step 2, you get the level of significance. Of course, given naman yung level of significance. So in here, we have 5% or 0.05 level of significance. Step 3, you determine the test statistic and the critical region. The test statistic here is z-test kasi greater than 30 yung number of samples or observations. And then, let's construct the critical region. Z is greater than the critical value. Z is greater than the level of significance 0.05. And then, Z here is greater than 1.65. Bakit 1.65 yung critical value? I'll show you. Actually, naara ni siya sa table class. Let's go back sa atong first table. This one. Again, we're using one-tailed test yung gagamitin natin for that problem kasi it compares man. It compares or determines if there is significant difference between groups in a specific direction because it really asks the alternative hypothesis if your present class is superior than the previous class. So we use one-tailed test. So again, 5% or 0.05 yung level of significance, 95% yung confidence coefficient, yung critical value niya is 1.645 kasi one-tailed test. Pag two-tailed, it's 1.960. Pero one-tailed naman is 1.645. So let's go back. So Z here should be greater than the critical value 1.65 for null hypothesis to be rejected. Okay. So step 4, you solve for z-test, of course, using this formula. I will not already discuss the meaning of each of these symbols. I already discussed this in my previous discussions or topics. So z is equal to, yung mga naka-highlight na orange class, by the way, are the given. So yung x bar, again, this is your sample mean, is equal to 85. Tapos yung population mean is equal to 80. Okay, divided by the population standard deviation, that is equal to 8, divided by the square root of 40 because that's the total number of observations or total number of students. So using this formula again, na substitute na natin, you will come up with an answer z is equal to 3.95. Dapat same tayo ng answer to know na tama yung ginagawa mo. Okay? So, last step, your step 5 is already the decision and conclusion. So, dito na pumapasok si decision rule, whether or not to accept or reject the null hypothesis. So, Z here is greater than 1.65, in which Z is 3.95, and it's really greater than 1.65. Therefore, here, based on our presentation, your null hypothesis is rejected and your population mean is greater than 80. Okay? Kasi your population mean is greater than 80. Let's recall the problem in here. So, I'm sorry. The problem is just here. So, the population, so, null hypothesis again, class is rejected kasi mas mataas si Z kaysa kay critical value na 1.65. Mas mataas yung Z value, so rejected na naman siya. And your population mean is greater than 80. Okay? So, ano ba yung alternative hypothesis natin kanina? The present class is superior than the previous class. So, ito, your present class is superior than your previous class, than his previous classes. So, na-gets? So, this is very step-by-step lang. Test on means for two sample cases. So, ito yung mga formula na pwede gamiton. So, this one for known, ito for unknown na mga. So, sa Z-test, isa lang yung formula for known. And for t-test, meron tayong unknown at known. Okay? So, this example is in your module. I got this from your SAS module. I'll not go over this na. This is the same with the previous problem, the one I stated earlier in the slides. So first, you have to set up the null and alternative hypothesis. Then the level of significance this time is 1, that's 0.01. And then you get the test statistic and the critical region. Yung test statistic is t-test. T-test kasi less than 30 yung number of observations. May 17 at may 17 at 11 patients. So use this for the critical region, yung t-test is greater than t 0.01 and absolute value of t is greater than the critical value 2.479. That's the time you can reject the hypothesis. Your null hypothesis, by the way. Pwede mo nang i-reject. Pag greater than 2.479. So, what is V class, by the way, is the degrees of freedom. You compute the degrees of freedom for t-test using N1 plus N2 minus 2. Okay? So, in here, 11 yung N1 plus N2 nga 17 minus 2 is equal to 26. So, yung degrees of freedom is equal to 26. So, pwede mo lang yan. You will be able to apply this later. So, solve for t-test. So, yung mga naka-orange again, these are the given values. Yung N1 is 11, N2 is 17. Your sample mean for um, the first one is 85. And then the second sample mean is 79. For the standard, this one for your, what do you call this? For your standard deviation, that's 4.7 and 6.1. So first is you compute the pooled variance for you to be able to compute the t-test. The formula for the pooled variance is this one. Okay? Just have to substitute everything. So, pag nakuha niyo yung 5.60, you are doing it correctly. Okay? I'll not elaborate this one by one. I guess you already studied and answered this as well already in your activity worksheets. So, 5.60, huwag kalimutan i-square root kasi pag may square pa, that's not the standard deviation. That is pag na may square pa, actually, that's not the, what do you call this, the pooled variance. Okay? So, let's proceed. Yung step 4, you solve for t-test. This is 4.2, you already solved the t-test using this formula. Your DO here, class, is number 8. Kasi you're asked if would you say that the diastolic BP of those taking drug A increases those of drug B by more than 8 millimeters of mercury or mmHg? So yung 8 dito is the DO. Okay? You solve this, you substitute the formula and you come up with T equals negative 0.923. Okay? So, the step 5, decision again and conclusion. Dito na rin pumapasok si decision rule. T is greater than 2.479. Dapat, di ba? So, negative 0.923 is not greater than 2.479. Supposedly. So, if it's not greater, basically siya sa accepted region. Okay? One-tailed test lang din yung ginagamit dito. Hindi ko na-draw or nalagay yung picture. But this one, 0.923 is greater than 2.479. It can be rejected natin yung HO. Okay? But this one, 0.923, hindi naman talaga siya greater than 2.479, it's less than your 2.479, meaning na siya sa accepted region, so you accept your null hypothesis. Therefore, drug A does not increase the diastolic BP compared to the drug B by more than 8 millimeters of mercury. Okay? So, test on means for two sample cases. These are cases that are related or paired, no? For example, you have cases like the one in your module, yung mga related na sample cases, like an exercise therapist measured the heart rates of 15 randomly selected patients. The patients were then placed on a running program, and their heart rates were measured again after a week. The results are as follows. So ito, you're comparing the heart rate before and the heart rate after. You may use t-tests that are related or paired. Okay? So lastly, ito yung statistical table. You neglect Einstein's formula. Ito yung statistical table for your z-test. And then this one, the statistical table for your t-test. I hope or I believe I already shared to you the different statistical tables. It's in the folder of our lecture SAS modules. Nandun yung tables ng statistics. So in here, like kanina t-test, 26 man to iyahang critical, I mean, not the critical. 26 man to yung degrees of freedom, right? 26 yon. And then it's a one-tailed test na 1%. So, 1% ito siya. Kasi kung ito na 1%, this is two-tailed. 1% na one-tailed test, 26. That's 2.479. So, 2.479 talaga yung critical value. Okay? That would be all, class, about the different about parametric statistical inference. So thank you so much for listening. Have a great day.